So, welcome to my presentation on offline first computing in an online world. My name is Ørnulf Staff. I work at Kongsberg Defense and Aerospace. My day job is doing our own DDS implementation. Now, if you don't know what DDS is, I'll also explain this during the talk. We're not too big of a crowd, so feel free to ask questions. I mean, if you're wondering about something, then somebody else is probably wondering too, and they're just too timid. So please just ask. The talk is going to be somewhat technical. I'll try some live coding. That's always fun. But it's not going to be an algorithmic deep dive. I'm not going to show any theorems or lambdas or lemmas or stuff like that. It's no computer science proofs here. And also, it offline first versus local first, it's kind of the same thing. But I thought I'd start out by, well, there are no acronyms in the title. I tried to make it a bit more catchy, but the description mentions both DDS and CRDT, so I thought I'd just start there, just expand the acronyms before I start using them. So at the end, CRDT is conflict-free replicated data types. Okay, so what does that mean? Well, it's a data type. Okay, so it's any type of, it can be a string, a map, or graph, or a tree, or usually something complex. It's replicated, meaning it's a value type in the sense that you can have multiple copies of it. And so far, this is any data type in your standard template library is then sort of fulfills replicated data type, in that you can copy it. But then the conflict-free, that's the special magic. Because it means that it has a built-in mechanism to resolve conflicts. So that if you have a map here and a map, you copy it to a map over there, and then you make concurrent changes to both maps, then if it's a conflict-free type, you will have a way to merge those maps again and have one single correct value for that map. And typically it means you'll have the ability to get a patch from this map and a patch from that map and apply them interchangeably, and then you'll end up with the same result on both maps. So, for instance, an integer in itself, it's obviously it's a data type, and you can replicate it. You can copy an integer value everywhere. And then if you say, for instance, highest value wins, then it's conflict-free in a sense, because then you've resolved it. Because then if you change the integer over here to 4, you change it over here to 7, and then you merge them, then the correct value is 7. You know the correct value is 7. And that's, so how's that useful? We'll get back to that. DDS, on the other hand, is data distribution service. Okay, tells you nothing. It's a standard for publish-subscribe systems. And so DDS is, well, it's a standard by OMG. I'm getting ahead of myself because I'll cover all of this later, but, well, just say it's a publish-subscribe thing, networking type of library. But I thought I'd start with this offline first thing, because, well, offline first, that's, what's that? If we assume that this guy he doesn't have 5G in the Palm and he didn't bring Starlink, so he's actually offline, then what can you tell about his computing environment? Then, of course, whatever he's going to do on this island, he has to have brought with him, because he has no external input. So it has to already be there. And so if he worked on software code, for instance, then if you used ClearCase or one of those old version control systems, he couldn't really do his work. But if you used Git, probably he would be good. He could work on this island and commit his code and do stuff, and then he could deliver the code later on. But Git, on the other hand, it's not conflict-free. I mean, raise your hand if you used Git. Raise your hand if you used Git and never had a merge error. So it's not strictly conflict-free, but it still enables use of sort of offline or local usage, because you have a clone of your data. So if he used that, he'd have it on his island and he could work on his repository. But then offline first, it kind of applies that there's a second, right? If you're just offline, then you're offline. But if you're offline first, then what comes after? And that would be some kind of networking, because you want to be able to synchronize your data somehow. And then question is this related to network architecture? And the answer is kinda, but not really. Again, if you look at Git, very often these days, Git usage is through GitHub. And then effectively you have a client-server architecture. But it's still, you have this kind of local first capabilities, right? Because you have this clone of your data. And of course you can use Git in a peer-to-peer way, in the sense that you have a repository, you have another repository, you can always just pull changes from one to the other. You don't have to go through any type of server. So it's kind of related, or I guess if you're doing local first type of architectures, then you'll tend to support peer-to-peer networking better, but it's not strictly speaking a requirement for this offline first type of concept. But then, sort of on a tangent, there's this, not conflict, but well, you can look at consistency versus availability in a sense. And what I mean by that is that if you want to have something consistent, then you need to sort of be able to lock that resource, or very often, I mean, in an online setting, if you're selling tickets to a concert, then you don't want to sell the same ticket twice. And so then you put a really high value on your consistency. On the other hand, I mean, again, Git is a proof that we're sort of willing to forgo the use of, or the ability to lock stuff. You cannot really lock anything in Git, right? Everybody can work on anything, and then you fix it afterwards by merging. And then effectively, you're putting a higher priority on availability. So, and a lot of, I think, a lot of effort in sort of the cloud domain is on consistency. You have all these fancy consensus protocols to be able to make sure that you have one true view of the world. So because, I mean, consistency is very easy if you have a single source of truth. If you have one program, then you know what the value is inside that program, and that by definition is your truth. And then in the cloud world, you find that, okay, but I need to scale up, I need redundancy, I need multiple copies. But then you try to sort of maintain the consistency, and you get these election algorithms, for instance, to make sure that you have a majority of your servers agreeing on something, and then you know it's the truth, and then you can move forward. But for other applications, availability is more important. So, I mean, I work for defense and aerospace, right? So that's the part of Kongsberg where things can blow up. And then if half your system has been blown up, the other half should continue working. So it will work imperfectly, but it's better that it does something than that it does nothing. So you don't want to make sure that you have a voting majority before you do any change to the document, for instance. You want to be able to change this thing. And then it might be that somebody is doing a conflicting change, but then, yeah, it's still better to do something than to do nothing. So, sort of going back to this offline first, what it kind of implies is replication, I think. If in any sense of the way you're going to be offline first, you're going to have your data locally. It must be available where you are. And I mean, it could be inside your specific tablet, or it could be a network resource that you have available inside your car or inside your boat or wherever you are. But you need some kind of local data system. And Also, allowing local edits. So if you have this local data, then allowing local edits, sort of you have to embrace the concept of eventual consistency with emphasis on eventual. It might not be, it's not sort of a failure state that you're trying to fix, it's just they're different because you've done something, I've done something, we haven't merged our work yet, but that's fine. And the system kind of have to live with that. It's more like the real world in a sense, where you cannot really know anything, but you know what you know. You have your own source of knowledge, and it's imperfect, but it's better than, well, you don't have a better option. So you live with that uncertainty. And so, but effectively, at the end of the day, on these locally changed replicas, you need some way to resolve merge conflicts. And then conflict-free sounds awesome, right? So with that, I thought I'd go a bit talk about the DDS first, because data distribution service, this is about moving data around. So that's sort of one half of the equation that you need, because you have the replicas with the CRDTs, and I'll get to those. But first, you must also be able to move your data around, and I'll try to show how DDS can be used here. First, that I have this quote about DDS is the best kept secret in distributed systems, which would be a really nice thing if a food critic says that about the restaurant, it's a very compliment. If the restaurant says it about itself, then it's a bit more dodgy. And this is from the Cyclone DDS, which is a DDS implementation README. So I mean, and I'm not sure if I should say this either, since I'm also implementing DDS. So, so I guess we're a bit insecure, but we think DDS is awesome anyway. So it's a standard. It's made by Object Management Group of Corba fame, and also UML. And also DDS. So yeah. But it's one nice thing about it is that it's available on omg.org. So it's a set of standards really. But anyone can go there and download the PDFs and implement their own if they want to. There's no registration even required. You can just get all the standards, which I think is really great. More specifically, it's a brokerless, so serverless. There's no server here. Actual serverless, not the cloud serverless kind of serverless. Peer-to-peer, publish, subscribe library. So, well, the standard isn't the library. It's a standard, but any implementation of the standard is probably going to be a library. All I know of are. And publish, subscribe here, that means that you're using this library, you're writing stuff, you're not addressing some endpoint, you're addressing a topic. You're publishing GPS coordinates, for instance, and then there may or may not be subscribers that are subscribing to GPS coordinates, and they will then receive these coordinates if someone is publishing. But there's no, there's a level of interaction between sending and receiving. So that's the publish, subscribe. The API is, well, it's not offline, you can say, but it works on local data. So it's kind of, at least it's local first, in the sense that when you read something in the API, you're reading a local value. So it's very, well, it helps you write programs that are robust because, or resilient to network outages, because you don't have a function call where you read stuff and then suddenly that read stuff function hangs. The read in DDS is non-blocking, always. You do of course have a wait, but then it's called wait, and you can intuit that it's going to wait. There are several implementation. Intercom DDS from Kongsberg is one of them, and there are RTI is a big company doing DDS, and there are several open source versions like OpenDDS and Cyclone DDS. I have some links at the end I thought I'd put up, so you can, if you're interested. I'll leave that up at the end. And then, yeah, last thing before we go to the live coding thing. I thought I'd talk a bit about DDS discovery, because when you don't have a server, then discovery is kind of one of the difficult parts. Or how do you discover other things? And the answer for DDS is multicast. That's the standard answer, or DDS standard answer. So if you create a participant, a DDS participant, it's going to publish announce messages on multicast. So it's basically sending out to the network, I'm here, I'm here, I'm here. And then what happens when another participant receives this message? It's going to see that, okay, this is an announced message from somebody I don't know. And it'll answer back with the information about all the topics, all the readers and writers it has, and the quality of service. So basically all the settings for these readers and writers. It's going to send that back. It's also going to send an announced message back, or it'll just do that on a regular basis. And then the participant A is going to do the exact same thing and send all its information to participant B. And I think the neat thing about what happens then is that both participants will then have the same data, because participant A, he knows everything about himself, of course, and he also knows everything about participant B, and vice versa. So then you can, on both ends, you can run the same algorithm and come to the same answer. So participant A will see that, okay, I'm publishing a topic on coordinates. I'll start sending those to B because B is interested. And B on his side will see that I'm subscribing to coordinates for topics, or a topic for coordinates. And participant A is publishing that. So I'll start subscribing to this. I'll make the internal structures ready to receive data from A. And there is no further handshake, because you're running the same algorithm with the same input data, or it's pure functional programming, right? You use the same function with same input on both computers is going to come to the same conclusion. So they work this out independently, don't need to do a handshake. So you move directly from this generic exchange of information to application data. No agreement protocol that you should send me data, which is sort of a neat detail. And also fits into this type of local first computing. It's the same kind of thing that you will have to do there to implement. Then I thought I'd look at chat, because, well, I'm sorry, but publish, subscribe, the simplest thing you can possibly implement is always some kind of chat. So that's what I'm going to do too. And I thought, well, let's see if I can make this actually readable, like this. Yeah. So I've set up a project for myself to not waste time doing searching for the correct path in CMake and stuff like that. And what I have here is I have this IDL file, which is a message definition file, basically. That DDS use it. It's very similar to what you have in the protobuf file. And you can use it to define data types. So module chat, that's namespace chat in C++, will have a struct message. And the message is going to contain 2 strings, the user and text. Also, I'm going to cheat a bit here because I put this topic annotation on. And that's not, strictly speaking, a part of the standard, or annotations are, but what you do about the topic annotation isn't. But it allows us to generate some further code, so I don't have to type it all out myself. So it'll make my chat application a bit shorter than it would have been if I didn't use this. So then to implement my simple chat, I'll start by including the sort of top level include the DDS header to get my hopefully autocorrect working. IntelliSense, I mean. And with that in place, I can then create a domain participant. Main participant, DP, and it will join domain 17. Now, what this is going to do is it'll create this domain participant object, obviously, which is something that holds, well, it really is the owner of the discovery mechanism. It's the owner of all the sockets. It's owner of shared memory areas. So it's the heaviest object in the DDS world. And generally, your application will create one of these or several of these at startup, and they'll live throughout the application lifetime. Very often, you can create them at any time, but also since this is multicast discovery, it really doesn't make sense to create one of these, read one value and destroy it, because that's going to be very slow for you, and also probably the lifetime of this is at least a few seconds in normal cases, because again, yeah.
I was just wondering, you choose domain ID number 17 there. Is that something you choose completely arbitrary for this example, or is there like IANA well-known numbers?
Good question. So the question was, what domain ID 17, is that a significant number, or is it just a random number I picked? And the answer is it's a random number. So the domain ID is a way to make to be able to have separate DDS or DDS networks that don't conflict with each other. It's an integer between, it's a 32-bit number, so 0 to up to 31. 32 actually, 4 billion. It will map to different UDP ports numbers in a standard way. But of course, there are more domain numbers than there are UDP port numbers, so they will collide at some point. But if I do 17 and then I did 18, they two wouldn't communicate, and they would be sending data on different UDP port numbers. But there's no IANA or no, well, since DDS uses different port numbers for different domain, it basically uses any range of UDP ports that you want. So it's not, there's no specific DDS port. Yes? Yeah, good question. So the network bound on the domain would be, by default, it would be decided by your multicast routing settings. Again, well, then you go into the standard doesn't say anything about this, but we have a configuration file for our DDS implementation, and it allows, among other things, to set this thing. So this sets the TTL value for the multicast messages, and then your network will, and they're sent to, by default, again, this address, 233.255.0.1. And so anyone who sees this message will try to start this handshake thing. But it's then up to your network, really. But the answer is that most of the time, DDS is used sort of on a local network, in a sense. So very often it's physically local, so inside a vehicle or inside a boat again. Or yeah, so some physical area, or some kind of VPN network maybe. So you have a local network. It's not necessarily physically local, but it's still a limited number of computers, because generally you don't want to address the world like this. And also, since all of this communication is point to point, and everybody inside a single domain is talking to everybody else, if you try to put 1 million people in the same domain, that would be like 1 million people in the same room all trying to talk. It doesn't work. So you need this mechanism to, the domain mechanism, I mean, to be able to sort of control the number of participants in the domain. They should have something to talk about, some reason to communicate, if you will. But of course, you can grow your network, but at some point you will probably need separate domains, and then you'll need to create someone on a higher level that sends data between those two domains if you need that, for instance. But it's left to the application. So a domain is a sort of flat network. Okay. So I have my domain participant. Then let me try if I can create. I'll need to include my generated code, chat/reader, and I'm also going to need a writer to do a chat, so I'll just include that. So I then want to create, I can scroll up a bit. Reader, like this, and it takes the domain participant as an input. So it is created as a reader under this domain participant. And then what I want to do is whenever I receive some data, I just want to print it out to standard out, because that's the easiest thing I can do. So let me just fix this up to lambda. Sample, something like this. Something like that, and also here. No. There I go. And then I'll just print it out. So, and my message had a name and a text, so sample data message is sending, no, it's not message, text, the user, like this. So user is writing something. And that's really all there is to it. This will create a reader that will subscribe to my topic, and whenever it receives data, it's going to print it to standard out. So that's the read loop of my chat application. And then to create the write loop too, I need first a writer. Chat topic writer. And then I'll need a message to send. So I'll initialize that with my username and just an empty text. And then I'll do a simple getLine loop to read data from standard in. I'll getLine like so. And then to publish this sample, I just send it to the writer. And that's it. So this, hopefully, is enough to, and correctly written. We'll see. Oh, it compiles. So we're all good. I cheated and created some terminals for myself to be able to test this thing. So it ends up in build, and I have the simple chat over here, and this is the simple chat I just made. Let's check if yeah. So this is recent, right? This has been made right now. I can run it. I can call myself Bob. I can say hi. There's nobody else here, so it's not really going anywhere. But you can at least see that it's looping around because he's talking himself. Because this line here, Bob's colon hi, that's from this line here. So this you see it's getting published, it's getting picked up locally, but it's not being sent anywhere. And oh, actually, I have something else running. So that'll mess up my diagram a bit, but that's okay. I can start another one. Let's say Bill comes in. And Bill then gets sent the message hi immediately from Bob. And this happens because inside the DDS library, the message from Bob has been stored. So the DDS or intercom DDS knows then to send it immediately on connect to the new application. But the message lives inside the Bob process. And Bob can then say, Bill can say hi, Bob. And then, yeah, again, it's messing a bit. I have another application running somewhere. But you see then what happens is that the hi message gets sent to Bill. And when Bill responds, he sends hi, Bob, back to Bob and to this mystery chat application that's running somewhere on my DDS domain. I don't control where, so there's... and if we extend this a bit, or yeah, let's add another participant. Build sample simple chat. Alice joins, and she says, "Good morning." And it goes to all the others, and you can see then in my nice diagram that she's sending it to both. First, she gets the existing messages from the other participants, and then she's answering good morning, and the message is being sent to all of them. Now, at this point, I hope that someone in the audience is thinking that, yeah, okay, this is a cool chat app, but what about this diagram? That's being live updated, right? It's kind of cool, isn't it? I think it's cool. So, glad you thought about that. And because nominally, our component diagram looks like this. Well, we have Alice, Bill, and Bob, and then actually plus my mystery chat application somewhere. Don't know. Sorry about that. But my actual chat application, there's one more participant here, because the full component diagram looks like this. So I have my slides here. My slides showing is in a web browser, and the slide server is a DDS web server, basically. So it listens on DDS. It participates in the same DDS domain. Doesn't listen to chat messages though. It listens to these CRDT messages. So it listens to it listens to a CRDT document that I'm creating in another program called the Mermaid generator here that listens in on the chat messages, and then it's not actually showing the DDS traffic because it's cheating. It's recording what's happening on the chat domain, and then it knows what the traffic is going to be to fulfill that, because I know what DDS is doing. But essentially the Mermaid generator is creating this document up here. So whenever you do anything, a line will be appended to this document. And then this diagram here is simply a render. It's a Mermaid render of this text here. So easy, right? Actually, it's it's not that difficult, which is the cool thing here. And that brings me, I think, over to Automerge, because, yeah.
So Alice joins, she gets the previous messages.
Yeah.
So how long is Bob and Bill holding on to those published messages?
Excellent question. It depends. It's I didn't show you, but in the chat IDL, it's referring to a quality of service setting, and this quality of service is defined in a JSON file. And here you can, for instance, on the writer side, you can set a bunch of configuration settings. And transient local means that it should keep data for late joiners. So that's what's making it store it. If it said volatile there, then Alice wouldn't get the old messages. They would have been deleted. Whereas keep all history means that all the chat messages Bob is producing will be queued up in his local storage. He could have keep last there instead with a depth of 1 or 10 or whatever, and then it would keep the last sample. And also, you could put a lifespan here, for instance, to say that the messages should live for 10 seconds or 10 days or whatever. Well, generally, this setting here with transient local and keep all wouldn't be advisable in the running system because this will make Bob keep his messages around forever. So, yeah, you generally, when you create or when you architect the DDS domain, you have to make sure that data is thrown away. And DDS gives you a lot of knobs to turn to tune your topics so that the correct data is thrown away at the correct time, basically. Yeah. And then just to prove that this document is the same thing, if I answer hi again down here, then you see that's appended in this document. So far, I mean, this is neat, right? But the flow of the information is just from this application through the DDS domain to the slide server to the browser. So it could have been just any text, right? There's no it's replicated, but there are no concurrent changes. So I don't really need the Automerge or the CRDT functionality, but then still I used the CRDT for this because that's what I had, because that's sort of the goal of this talk. Which brings me to this Automerge library. It's an open source project. It's a library. They had a version 1, I think, in JavaScript. The version 2 is written in Rust. It has C bindings, which is a pretty horrible API actually, but it's it works. But it also compiles to WebAssembly, so you can run the exact same library. So it'll be consistent with itself, which is good, in the browser, and it has a pretty nice JavaScript API. And also the Rust API is also pretty nice. So it's easy to use this thing from either Rust or JavaScript, and possible to use it from C or C++. It's MIT licensed, available at GitHub. And also they have this nice web page. They talk about building local first software. So they're very much in line with the topic of this talk. And they have actually pretty nice documentation with design principles and how-tos and how to use it. And well, if you're interested in this, it's very much worth checking out. They also have links here to stuff like this local first software. Oh, that's yeah. Let's not go there yet. It's basically an essay on the field. It's interesting reading. And actually, to use Automerge, it looks like this. This is straight from their documentation, and it's also close to what inspired this talk, actually, because it uses the Automerge stuff up here, and then it says network broadcast changes, and then network receive changes. And I thought this, and I looked at this, and I thought, hey, I know how to do that. This is my DDS, isn't it? So how about I try to join the two, and would that work out? But to start at the top, an Automerge document is an immutable document, and so to change this, you call a change function that basically creates a transaction for you in this doc thing, and then you can mutate the doc however you want. And the document in Automerge is basically a JSON equivalent. So you have the document it feels like a JSON structure when you use it. and you can add another nested objects. You can add arrays, strings, numbers. And it'll create a new immutable document for you with those changes applied. And then you can do git changes to get the diff, basically, between your old state and your new state. And you can transmit those over the network. And then someone else receives them, then can apply them to their current state. And they'll end up with a new document that is identical to the new document up here, assuming that the current document was identical, right? But you can still apply it. So you can receive messages in any order. That's an important property of the CRDT. It's conflict free, but it also allows you to well, you don't need a specific ordering. If you did, it would be much more difficult to use. And then we can look at a to-do list. So that's neat, right? And now let me exit my full screen. And over here, actually, I have a different view running on a different server of what's going on. So this is the same diagram from my presentation, but the server is actually different. It's a different port. And I have a to-do list here, and they're linked. So whatever I do on this server is matched to whatever is happening on this server over here. And so they're communicating through DDS. And since the CRDT is conflict free and allows me to do edits wherever and just synchronize it afterwards, I'm guaranteed, as long as communication is up, their state is going to end up the same way for these things. And I can also add stuff here. So I can add another to-do item. And then now comes the very interesting part. You all could try to go to this web page here. Just visit on your phone or laptop or whatever. We'll see if the server melts. It's just a small computer at my house, so this might break spectacularly. But at least in theory, you should get this same web page. So first one in could go and edit the chat sequence and try to edit the name of Bob to something else. We'll see if it works. If I can load it. Yeah, it might. There's a risk that this part isn't working, but I promise you concurrent changes are possible. It's just... Yeah, no, maybe my... Let's see if I can ping the server. Oh, it is? Oh, great. Yeah. So it's yeah, it's network, but it's not, well, you can't see this, but it's not the load isn't that high actually, so it's the network that's melting. Oh, there, yeah. So then, yeah, yay, it's working. Awesome. So architecture then now, it looks like this. So you have this DDS domain that all the CRDT documents are communicating on. And you have my slide server, that's this window over here. that's hosting my slideshow, and you have the public server that you're all accessing, and then all the N browsers. And so I think that the magic of this is that it's still probably buggy. If you scratch this too hard, it's going to fail somewhere, honestly, because it's been, I've been doing this on my free time for the last 2 weeks, so it's not it's not a high quality project. But the thing is, this Automerge library really is kind of magic, because being able to apply changes like this, I do not have any complex change resolution protocol or anything like that. I mean, literally, the change code, I think I'll just try and show you. In my most interesting bit is in the JavaScript. It'll do, let's see. Yeah, here. So event data, this is triggered whenever you receive a message, whenever it receives a message from the DDS server. So this is basically, it's a DDS message received by the JavaScript application. It checks that the topic is CRDT because I have the same receiver here for everything. And then whenever it has, it receives a document. Oh, I should also show you the IDL because that it makes more sense then. So a CRDT message is defined as this. So it has a string, which is the document name. That's the thing you're seeing, oh, sorry, over here. So that's just a string document name. And then the content of the message is some CRDT value. And that can either be a complete CRDT document that you get from calling .save on the document, or it can be a change that you get when you call, well, you can get it multiple ways, but I'm just doing .save incremental because it's easy, which will save the changes since the last time you did save incremental. And that's transmitted. And that's basically what then any participant or any reader in the system receives. So then if I go back, it checks if this is a complete document. And if it is, it'll actually, here it will overwrite what it had already. So it will create a new document up here. Then it will get the change and it will merge the change into the new document. And it will call save incremental, which is really just a way to make sure that the next time I call save incremental, I don't have to retransmit everything it just received. So that's, you could skip this. It would just waste a bit more bandwidth. And then if it's a change, it will look if it actually has the document already. If not, it'll just ignore the change. And then it will do, well, here is using load incremental instead of merge. I can't recall why I did that, but it should be the same thing. And the point is, it's just one API call to the Automerge, and it will make sure that the change is applied to the document and then return a new document. It'll also, you can also here get information about what was changed, so that in a more advanced user interface, you'd probably want to show to the user if there's a conflict somewhere. And you can get that from Automerge. It can tell you that these concurrent changes change the same line. So there's a conflict, and maybe the user has to then make a determination what is correct. And also, what's worth noting here is that Automerge will guarantee that the state is the same on both systems or N systems after you merge all the changes, but it will not guarantee that the merge is in fact what you want. It tries to be smart. So, and usually, I mean, it works out pretty well, but there's no guarantee that, for instance, well, this thing here is never going to be syntactically wrong because my language is just if the line starts with an exclamation mark, it's done. If it doesn't start with an exclamation mark, it's not done. So this grammar is any text will parse. But with the diagram, you can edit this, and then if I remove something here, it's just going to be a parse. Well, you can't really see it, but I mean it's an error. It's no longer a valid mermaid diagram. So there is no guarantee that this will be maintained. And for my use here, I've simply used a single text field. That's all they're being used. And that works fine, but Automerge, as I mentioned, it supports pretty much any JSON object. So you can do a structured change, which then will allow you to guarantee the structure of your document, because you're only making the correct structured changes to your CRDT or Automerge document, but still it doesn't guarantee that it's semantically consistent. So then you might have somewhere in then your JSON-like structure, you change some value to something and another value to something else, and they're in conflict. So it might not make sense. And then so you, I mean, you will need, if you use this for real, you will need to resolve those things. Yeah. And then another thing to be aware of is that whenever you're changing in your input area, when you're writing something, my first naive implementation of this, I just got a notification that the text in the text box was changed. Okay, so I thought I'll just change the text in my Automerge document. But then you get horrible merge performance, because, or then what happens is that you're telling the Automerge to replace content with this content, replace with this content, and replace with this content. And then effectively you're not going to see any merges, you're just going to see one of those values winning. So then if you have concurrent changes, there'll always be a huge conflict and one value will come out on top. Automerge will guarantee that, but it's going to be one of them. So to get a useful sort of concurrent behavior where you can, where you were able to type this stuff in and at least some of it makes sense, then you need to tell Automerge what's happening. So you need to tell it that it's going to insert text or insert at somewhere. It's going to do delete at somewhere. It's going to, well, basically, yeah, tell it what the edit is. And then I still have a couple of minutes. So I thought I'd do a bit more about this CRDT and what there actually are, because it's useful to know something about them if you're to use them. And Wikipedia has this to say. It allows you to update replicas independently without coordination. And the algorithm for conflict resolution is part of the data type. And that's, yeah, it is. And they are guaranteed to converge eventually. But eventually here means that they're guaranteed to converge whenever they have the same information, which might be never, but they cannot be inconsistent if they have the same changes applied to them. That's not allowed. I'd add, I'd stress a bit that you end up with the same state if they have the same changes. So that's another way to phrase the last thing. But and the other is, I'm not sure if this is, well, CRDT is not, it's not like a protected thing, so I guess you can say this. But it should be possible to apply changes in any order, because you cannot know. I mean, I may receive some changes from someone else and from someone else, and I apply them, and that should be order independent. And that's an important property, because that makes it much easier to work with the CRDTs. And I mean, what's happening here, when you all had your browsers out and did changes to the document, then I would receive them here in some order, and someone else would receive them in a different order, and there is no clock. And that's really, actually, that's point 3, that the CRDT, or a good implementation, it shouldn't care about time of day. Simply because most of it's very hard to know the correct time of day often. And it's just more robust if it doesn't care. And then I thought I'd do just a couple of quick examples. So if you have a simple thing that does add, you have a number, you're always adding. So then if you add 1, you both get 1. You add 2 and you add 3, you get different states, but that's okay because you've added different information. And then you switch it, so you add 3 and 2 and you get to the same answer. So plus operator basically allows an integer to be a CRDT. On the other hand, if you mix, add and multiply, it's not going to work, because 1 plus 2 multiplied by 3 is not the same as 1 multiplied by 3 plus 2. Again, you add 1, you multiply it by 2, you get 2, you add 3, you get 5, or you add 1, you get 1, you add 3, you get 4, and then you multiply 4 by 2, you get 8. They're not the same, so this wouldn't be a CRDT strategy for an integer. And more realistically, if you have a set, if the set is insert only, it's going to be a CRDT. Because anytime you insert a value, it's simply added to the set. And, well, actually, come to think of it, you also have to always use different keys here, wouldn't you? So you still need a conflict resolution if you're inserting the same value twice, because then order matters. So, yeah, let's just skip this. The last one is that if you do removal, it's definitely not CRDT, because then if you try to remove something that's not there, it's not going to be removed. And then if you add it later on, you're going to add it. So if you know 1 and 2, and you try to remove 2, you get 1. If you know 1 and 3, you remove 2, you still have 1 and 3. And then later on, if you add 2, you're going to, you're going to have different ordering here. So I guess the point here is that it can be difficult to delete stuff in a CRDT world. And again, intuition from Git is kind of useful, in the sense that if you have a branch in Git, it's very hard to make sure that it's gone from everywhere. If you really want to delete some data from a Git repository, it's going to take ages, because all the distributed repositories have to be changed. And if you manage to remove all the references, eventually it will be garbage collected, but who knows, it might come back later on. And we're very close to the end here. So there are a couple of challenges too, except in addition to deleting stuff. And that's basically related to how do you know what to transmit? When do you transmit? And I found a sort of a reasonable trade-off between too much retransmissions and having availability that actually worked. But it's possible to actually break the stuff that I made and demoed here. It's not bulletproof. And it boils down to probably you'll need some kind of watchdog to be able, or some mechanism to detect that two documents are in fact in a different state and you need to do sync. Because when you know you need to do sync, it's easy to do, but you have to know that you need to do it. And Automerge also then comes with a neat built-in function to actually resolve the changes. So you don't have to know what's the difference. You could just use Automerge and ask it to reconcile these two, and it'll do a network handshake. So you need basically a TCP connection or an RPC connection to be able to synchronize two documents. But you need to figure out how, or that they are different, I mean. So to conclude, replication and syncing is really cool if you want to, if you put availability very high on your to-need list. And you have to accept that the system is eventually consistent, but it's not consistent right now. So you have to sort of embrace that mindset that there is no one truth that everybody agrees on, but when everybody has the same information, they will agree, but they not right now. And there are ready-made libraries. I've talked a lot about Automerge now. There's also this YJS thing. That's primarily JavaScript, I think, but it also seems to be high quality and popular in the domain. And otherwise, you have, for DDS, you have open source alternative like Cyclone DDS and OpenDDS. Both are pretty good. And if you're interested in this local's first software thing, there's a link for that too. So with that, thank you. Yes.
I have some experience with Norway and the idea is similar to what you showed.
Yeah.
And one of the criticisms Norway has received is that the types that are used by the ORBs are kind of different, for example, from the C++ standard and difficult to work with.
Yeah.
How is that can be managed in DDS?
DDS has the same IDL, by the way. It's the same Corba IDL that's used by DDS, so it's the exact same thing. But it has two different mappings to C++. The legacy one that's used by Corba that mandates the same thing, but there's a new C++ mapping that will give you STD string, STD vector, and all that stuff instead. So there's a newer standard for it, and that's what I used somewhere over here. So in my message.h, no, chat.h, no, what's it called? Yeah, never mind. Point is, it's a string. It's the generator will create a string for us. But we were also we have many in-house projects that are struggle with these old Corba data types and want to move on, I think. Yeah. Okay, thank you again.